We are on page 337, and it says, in softball, a player's batting average is the number of hits divided by the number of at-bats. So hits, and it's divided by the number of at-bats. Okay, so if we're talking about Jamila, we're talking about 2 out of 5. If we're talking about Callie, we are talking about 1 out of 8. Mayumi, I've never heard that name. 4 out of 9. Elena, we're talking about 37 out of 99. And Casey, 7 out of 36. So, this one was an easier one. I do 2 divided by 5. 5 goes into 2 0 times. It goes in 4. So 0.4. This one, 1 divided by 8. 8 doesn't go into 1. 8 goes into 10 once. Put on some zeros there. That'll get me to 20. 8 goes into 20 2 times. That's 16. That's 4. So 0.125. So I'm actually going to put this up a little bit further. Mayumi, 4 out of 9. Erase that so that we'd have a little bit more room for Casey down below. 4 divided by 9. 9 goes into 4. No. 9 goes into 40 4 times. That would be 36. 4. Oh, look at that. Look what's going to happen. It's going to keep on repeating. So 0.4 repeating. It goes on forever and ever. Or 0.444. Boop, boop, boop. Ellipses. 37 divided by 99. Okay. Goes in, I would say 3 times because it's close to 100. Oh, no. Yeah, I'm guessing 27. Let's see, that's 27, 28, 29. That gets me 3. I borrow. That gets me 73. 99 goes into that 7 times. So 7 times 9 is 63. And that would be 63 plus 6, 69. I borrow. That's a 7. I borrow. That's a 37. That's where we started at. Look at that. It's going to repeat also. But this time it's going to be 0.37, and both the 3 and the 7 are going to be repeating. And last but certainly not least, I'm going to write Casey a little bit higher, just so that we have some room here. So 7 divided by 36. I'm going to say that goes in 1 time. Don't prove me wrong here. That's going to be that'll be 4, 34. Okay, I was right. Ooh, 3, 6. I want to say 8, but I'm not sure. That would be 48. That would get me 24 plus 4 is 28. I don't know. Let's see. That's a 2. 52. Oh, yep, did that wrong. Have to start from the beginning there. So 7 divided by 36. I guess that goes in more times. So 36. I borrow here. 6. that would 4, that's 34. So that's going to be 9 times. So that's 54. 27 plus 5, that's 32. And here they go. So that's a 6, that's 16. So that's 160. So 36 goes into 160. 1, 2, 3, 4 times. 4 times. Sorry, everybody. 12, 1. Oh, I should have known that one. Okay. So we've got 26. Oh, we're just going to keep on going, aren't we? So that's 0. So it'll go in 3, 6, maybe 7 times. So that's 42. Oops. That's 21, 25. And that's going to be an 8. What does this say? Each player's batting average is a decimal. Well, I guess we're just going to keep on going. And that'll go in twice here. Is that right? So this would be 72. Oh, look at that. We're going to have 8. This 2 is what's going to be repeating. So we have 0.1947 and then the 2 repeats, or 0.1947222, beam, beam, beam. There we go. Okay, so then down here, before I go into this part of the lesson, I actually want to see if, I don't think I can do it on here. Let's see. If I have a little bit of space off to the side over here, and we are going to talk about something that you should have learned before. The very first thing I'm going to talk about are what are called natural numbers. And that's 1, 2, 3, going on forever and ever. Okay? It's not negative numbers. It's not 0. It's just the positive 1, 2, 3, 4, no decimals, no fractions. Okay? Then, sometimes counting numbers. Then we have a group that are called whole numbers. Okay? And that's 0, 1, 2, 3. So it adds on the 0 to it. Then get a little more on the outside, and we have what are called integers. Integers are a whole number and its opposite. So now we're going to have some negatives along with it. But if you notice, we still don't have decimals. We still don't have fractions. All we do is have integers, which are whole numbers and their opposites. Then we're going to add in those decimals and those fractions. Okay? And that's what we're doing right now. We have this right here. These are going to be rational numbers. And that's what we're talking about today. So I'm going to come up here and we're going to look at this. It says a rational number is a number that can be written as a ratio in the form of A over B. Okay? Where A and B are integers and B cannot be 0. That means 0 cannot be in the denominator. Every rational number can be written as a terminating decimal, meaning ending, or a repeating decimal. Okay? So, down here, That's what irrational is. Okay, so if we're doing this, it's written as a fraction. And b cannot be 0. It can be terminating decimals. I love how I'm going in a circle here. And it can be repeating decimals. Okay? Those are our rational numbers. It can, guys, that means 4 can be written as 4 over 1. 10 can be written as 10 over 1. It can also be written as 20 over 2. Okay, so then we have over here an irrational number is a number that cannot be written like this. Okay? Square root of 2. Square root of 3. Pi. Let's see, what's another one that we know already? Oh, wait, non-repeating, non-terminating decimal. And that's what pi is. Okay? So, those are important vocabulary words, guys. Important vocabulary words. So this right here, that's a terminating decimal. This is a terminating decimal. This is a terminating decimal. This right here is a repeating decimal because the decimal repeats itself. Okay, is every number rational? Consider this decimal. Does it repeat anywhere? 3, 4, 5, 3, 4, 5. But then it changes to 6, 3, 4, 5, 6, 7. So it doesn't repeat. So it says, does the decimal appear to have a repeating pattern? No. It adds in new digits. Okay, it says 3, 4, 5, 3, 4, 5, but then it added in the 6, and then it added into the 7, so it has new digits. Do you think 3, 4, 5, 3, 4, 5, 6, 3, 4, 5, 6, 7 is a rational number? No. It is not repeating nor terminating. Okay? If you have learned that pi is the ratio of the circumference of any circle to its diameter. The decimal value for pi is shown below. Okay, notice how it doesn't repeat. Pi is an irrational number, but can be written as a ratio. How can this be? What do I want to say? Measurements are never perfect. Oops, there should be an R. Perfect for the circumference. Because if you think about it, if I was to do the circumference, it may be off for one person. It may be a little bit off from one person to the next. Okay, it's never quite exact. There are two ways to write a repeating decimal. You can use the ellipses, which are these 3 little dots right here. Or you can write it with the bar over the part that repeats. So we're going to convert 1/6 to 1/36. So 1 divided by 36. So 0, 0, Oh, didn't we just do this one? 1/36th? Yeah. Oh, no. We did 7/36. So that goes in 2 times. So that would be 72. I'm going to make it a little bit bigger so I can see it. That would be 9. So that's an 8. That's a 28. 36 goes in 1, 2, 3, 4, 5, 6, 7 times. So that would be 42. That goes in, that's 21, that's 25. Borrow. That'll get me 8. That'll get me 28. Oh, look at that. That's where it's going to repeat. Because 7, that 7 is what's going to repeat. So 0.0, oopsie daisy, 027 with the 7 repeating, or 0.0277, blah, 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 blah. Okay. This next one, it says, a basketball player's free throw percentage is 82.5%, or, remember you moved the decimal point over to make a percent, or to make a decimal from a percent. Write it as a fraction. Okay, so the very first thing that you have to do is identify the place value of the last digit. So this digit right here. Used to determine the denominator of the fraction. So, if you don't remember, this right here is the tenths. This is the hundredths. This is the thousandths. Okay? So, we are going to put that over 1,000. Okay? The digits to the right of the decimal point are the numerator of the fraction, so right here. And then the denominator is the place value of the last digit. So then we need to figure out what goes into all of this. Okay? So I personally, anytime something ends in 25 or 00, it's always divisible by 25. So I'm going to go ahead and use 25 myself. So 825 divided by 25 is going to get me 33. And 1,000 divided by 25 is going to get me 40. And there you have it. You have the answer in lowest terms. We have simplified it to lowest terms. So you can also convert a repeating decimal to a fraction. So we're going to write 0.5 repeating as a fraction. Okay, let x be the given decimal. So all they did was take x and they wrote it out with the ellipses. And we repeated a few of the digits. Now, what place value is repeating? The tenths is what was repeating. So we're going to multiply both sides of the equal sign by 10. So what they've done is multiply this by 10, multiply this by 10. When you multiply by 10, all it does is move the decimal place over 1 time. Okay? So what we're going to do is we brought this down here, and we brought the original equation down here. And we are going to subtract it. Okay? So we're going to take 10x and subtract x. We're going to take 5.5 repeating and subtract negative 0.5 repeating. When we do that, we get 9x equals 5. So then I'm going to divide both sides by 9 and get 5/9. Okay. And I don't like that we went ahead and went straight to that. But there's nothing over here that I can. So I'm going to do it over here. I'm going to give us, oopsie daisy. I'm going to give us one over here. So if I had x equals, I don't know, 0.3 repeating. So I would go ahead and write that with a few ... Since we only have one place that is repeating, I'm going to multiply both sides of the equal sign by 10. And when I do that, I get 10x on the left-hand side. On the right-hand side, I'm moving my decimal over one spot. Why did I write 10? 3.333. Okay? Then I'm going to bring this down here. X equals 0.333, blah, blah, blah. And I'm going to subtract this. That's what I'm doing. I'm subtracting. We just did systems of equations. We're subtracting. So 10x minus x will get me 9x. This cancels out. Those threes cancel, and I'm left with a plain old 3. I divide by 9 on both sides, and I get x equals 1/3 because I need to simplify my fraction. Okay, so this next one. This time, it's not one digit that's repeating itself. It's 2 digits. So I'm going to want to move my decimal point over 2 times. And in order to move it over 2 times, I'm actually going to multiply it by 100. So we're going to multiply both sides of the equal sign by 100. So if I multiply by 100, I'm going to move the decimal point over 2 times. So I get 18.1818. Okay, I just brought this down and I'm subtracting it. So 100 minus x will get me 99x. This 1818, that cancels out and I'm just left with an 18. I divide by 99 on both sides and I get 18 over 99, but I need to simplify that. 9 goes into both of those and I get 2 over 11. Okay, so let me come over here, pick another color, I don't know. X equals 0.45 repeating. Okay, so 2 spots. So I'm going to multiply by 100 on both sides. That means I moved my decimal over. Oops, I didn't mean to do that. I bring this down below. X equals 0.4545 repeating. I'm going to subtract. When I subtract, I get 99x. These cancel themselves out, and I'm left with 45. I divide by 99 on both sides, and I get x equals 9 goes into both of that, so 5 over 11. Okay. The average number of goals scored per game for a soccer team is shown. Write the rational number as a fraction or mixed number. Let x be the given decimal. So here, the average number of goals scored per game for a soccer team is 1.62333333. Okay? Multiply by a power of 10. So that means how many decimal spots am I going to want to move that over? Okay? So where does it start repeating? It starts repeating right here. So I'm going to move it over 2 times. So if I'm going to multiply, or if I want to move it 2 times, then that means I multiply by 100. So, guys, if you just want to move it one time, you multiply by 10. 2 times, you multiply by 100. 3 times, you multiply by 1,000. Okay? So, when I multiply it by 1,000, if I multiply it by 1,000, I get 1623.3 repeating. Okay? I subtract 1,000 and 100, and I get 900x. I don't know why I underlined that. Why did I want to do this? Well, that 3 cancels, that 3 cancels, that 3 cancels. I have no more decimals. So now I just need to subtract. 3 minus 2 is 1. Borrow. That'll get me a 6, right? That'll get me 1461. Is that right? I'm checking my work because 1623 minus 162. Yeah, I got it right. So I have 1461 divided by 900. I can divide that, let's see, by 3. Oh, it wants you to write it in a mixed number. I hate mixed numbers. I'm actually going to ignore that, and I'm going to simplify this. If I divide the top one by 3, I get 487 over 300, and I will leave it like that. I don't like mixed numbers. Okay. So converting this to a decimal. 1 divided by 18. Okay, it doesn't go in. Ooh. 100, let's see. How many times? Well, 20 goes in 5 times, so we're going to try 5. And if I do that, that'll get me 40. That would get me 90. Oh, that'll work. So 10. Oh, look, it's just going to repeat that. So it wants it as an ellipse. It wants it of an over bar. Okay. Use your calculator to find the decimal equivalent to the square root of 17. So if I was going to do, I would hit either, if you have just a regular calculator, you would do 17 and then hit the square root button. If you have one of the more advanced ones, you hit the square root button, then put the 17 in. So 4.123105625617661. Okay, do you think this is a rational number? No. There, oh, that's horrible. There is no repeating nor terminating decimal. Okay? Over here, write it as a rational number in simplified form. So this is ending, this terminated. That is the 1,000th spot. So 1905 over 1,000. And so, well, it helps if you know how to divide in your head. But if you don't, that's okay. So 381 over 200. Ooh, look at that. We have two numbers that repeat. So that means I'm going to do x. I'm going to multiply by 100. That's going to get me 82.8282, blah, blah, blah. If I subtract, these cancel, and I get 99x equals 82. Kimberly. Divide by 99 on both sides, and I get x equals 82 over 99. Let's see, 3 doesn't go into 82. 11 doesn't go into 82, so that's all we can do. This one, if I multiply it by 10, I would get 4.3 repeating. If I multiplied it by 100, I would get 43.3 repeating. Oh, I should write this with ellipses. Sorry about that. Okay. So I'm going to subtract 10x equals 4.333 repeating. These cancel, these cancel, these cancel. I get 90x equals 39. Divide by 90 on both sides. Get x equals, let's see, 3 goes in 13, 3 goes in 30. So 13 over 30. And then down here, the diagram shows the number of instruments in the string section of an orchestra. There are 7 cellos, 4 double basses, 11 of each of first violins, second violins, and violas. Use a ratio notation and decimal notation to describe the relationship between the number of double basses and the total number of instruments. So, the number of double basses. Okay, so that's 4. And now we have to decide how many we have of each. So I have 7 cellos, 4 double basses. I have 11 times 1, 2, 3. So that's 33. So that will get me 44. So that is 1/11th. And it wants us, that's ratio notation. So now I need to divide that. So 1 divided by 11. Okay, it goes in 0 times. It goes in 9 times. That would get me 99. And I subtract, I get 1. That's going to get me 0. And then I bring down another 0. And that would be 9. So 90 repeats. So 0.09. And that repeats. Or I could have written it as, 0909 ... Okay, is the relationship in part A rational or irrational? It is rational because it is in the form A over B. The ratio of 8th graders in the chess club to the total number of members is 0.45. Write it as a decimal. Write the decimal as a fraction. So I need to move it over 2 decimal spots. Okay, then I bring this down and subtract. Cancels, 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 cancels. All the rest cancel. I get 99x equals 45. divide by 99. 9 goes into both of those, so 5/11. A student claimed that a number, -4, is not rational because it is not a ratio of two integers. Do you agree or disagree? All integers can be written as a fraction -4/1, which is the same thing as -8/2, which is the same as -12/3. Pi is an irrational number. What can you say about the numbers? They are also irrational. An atomic weight of an element is the total mass of the protons, electrons, neutrons, and electrons. The ratio of the mass of protons and radon to the atomic mass of radon is that number right there. Write the decimal as a fraction. Okay, so I need to move these three numbers over. So I'm going to multiply by 1,000 so that I get 387.387 blah, blah, blah. I'm going to subtract 0.387. When I do that, I get 999x equals 387. Divide by 999, and I get x equals, let's see, 15, 16, 17, 18. Both of these are divisible by 9. 387 divided by 9 is going to be 43 over 111. So 43 over 111. Convert 1/15 to a decimal. Okay, so I'm going to change colors just so you can tell. So 1 divided by 15. Okay, so 15 times 2 is 30, times 4 is 60, times 6 is 90. Okay, so it's just going to be 0.6. Nope, I keep doing that. Or 0.06666 ... Okay. Mitchell was asked to write 0.616161 as a fraction. His work is shown. Do you agree with his answer? So let's go over here. So I multiplied by 10. Okay, and then he subtracted. I do not agree because this 6 should be under that 1 right there because he didn't line up his decimals. So what he should have done, and I'll change it again, is he should have multiplied by 100 and gotten 61.6161 ... and then subtracted. Notice how my decimal is lined up exactly. So this would get me 99x equals 61. So then I would divide by 99 and I would get x equals 61 over 99. Okay, so he didn't line up the decimals right here. He didn't line them up. Okay, so we're going to write this as, I do not like mixed numbers. 024 This is the thousandth spot, so this is going to be 1,000. Let's see. Does 4 go into 1,000? Let me think. Yes, 4 will go into 1,000. So I'm going to divide by 4 on top and bottom. And that will get me 1,006. And 1,000 divided by 4, that will get me 250. Oh, that's still even. So I can divide this by 2. And I'll get 503. And I'll get 125. Then this one. Okay, so my answer is going to be negative, guys. So 3, 9. Two numbers are repeating, so I'm going to multiply by 100. Okay, so negative 39.3939 x equals negative 0.3939. Now, if I'm subtracting, that means I'm changing the sign. So that's now a plus sign. Oops, sorry about that. So this will get me 99x equals negative 39. I divide by 99. 3 goes into both of that, so that gives me negative 13 over 11. So negative 13 over 11. How many spots are repeating? 2. So x, oopsie daisy. I'm going to multiply by 100. X equals 248.4848. Now, some of you may be asking, well, how do I know if I'm multiplying it by 10 or 100 or whatever? We want, when we write this down, when I go to write the x equals, we want these to line up. We want these to go away. So we know, we can tell by, are those lining up? Are they getting rid of the repeating part? So 99x, that was a horrible x, equals 246. Divide by 99. 99. X equals, let's see. Is that divisible by 9? That's 10, 12. No, it's only divisible by 3. So 3 goes into that 8 times, 2 times, 3 goes into that 33. So 82 over 33. Then this one. So multiply by 10 equals negative 11.111. Then x equals negative, nope, not 0. 1.111. Okay, so if you're subtracting, that means I'm changing this sign to be a plus. So I get 9x equals, cancel, cancel, cancel. That would be 10. Oops, sorry, negative 10. Divide by 9. So x equals negative 10 over 9. This one, I'm actually going to change the color so we can for sure maybe tell which one we're doing. So only one digit is repeating, okay? So I want to make sure that I get all of these digits on the left-hand side. So I'm going to multiply by 1,000 first. Okay, so 614.444 repeating forever and ever. Okay, but I also want what comes underneath right here to have the 0.444. So I need to move that over 2 times. Okay, I didn't mean to do that. Okay, I want that 0.44 to move over. So if I multiply this by, I want to multiply it by 100. I would get, let's see, 61.444. See, when I move that, these now cancel out and there's no more decimal. That's the whole point. So when I subtract this, I would get 900x equals, that's a 3, that's a 5, that's a 553. So when I divide, and that I think is just going to be that number, 553 over 900. Now this one, let's see, I'm going to work over here. Okay, again, I want this to come all the way over. So if I multiply by 100, that gets that repeating to be on the other side. But I want the 2's to line up. And if I only did the x right here, wouldn't I have 0.72? And this would not cancel out. So that's why I need to multiply it by something other than just leaving it as the x. So I'm going to multiply it by 10 so that I move that 7 over. Now the 2's are lining up. So now those 2's are going to cancel out. So this will get me 90x equals 65. Divide by 90. X equals 65 over 90. Okay. Yeah, there we go.